Hey, how's it going, guys? This is Max here, back with another game building tutorial using JavaScript and Kaboom.js on Replit.com. Today is a very special episode as we are going to be recreating Mario, one of the most iconic side-scrolling games of all time. This will give you a great idea how to build these kind of things with Kaboom.js. So you should definitely be excited for this one. So with that out of the way, let's get going. Okay, cool. So before we get started, I just want to point you guys over to the original tutorial that this video is based off of. It is on the Replit documentation, and obviously you can go over here and check out all the code we're going to be using. We're also going to be taking our sprites from here, which is very important. And it's going to explain everything a lot more in depth here. And basically each section has a block of code like the level over here, which you can copy and paste along with me, or you can pause the video and copy each section of code out if you prefer that. Either way is fine. So I will put a link in the description of the video for this for you, and definitely check this out. So with that out of the way, let's get started to build Mario. Alright, so we're over at Replit.com, and you can go ahead and create a new REPL. We want to use the Kaboom.js template, and you can call this whatever you want. I'll just call it Mario Game and create the REPL. So once your REPL's created, it should take you to your IDE. And we're just going to do some initial setup here. We don't want any of this code, but we do want to import Kaboom from Kaboom, of course, so we can use the Kaboom package. And we're just doing some initial setup here in our context initialization. We're basically just going to set a nice blue background and set the overall scale to 2. And that should give us a nice blue background to start off with. If you look in your file system, you've got sounds and sprites over here. You can actually delete both of these, as we're going to be replacing the sprites folder with the sprites that are going to come from the initial text-based tutorial. So go ahead and do that. So once you've pasted your sprites into your sprites folder, you'll notice that for our enemies and for our Mario itself, we've got JSON files. And these JSON files are going to reference the PNG files that we have, which essentially have different states for our characters if they're running or jumping, etc. And we're going to be using a separate method called asprite, and asprite is basically an external pixel art application that is going to help us to reference our various enemy and Mario states essentially from our JSON files. So over here I'm just going to say load sprites as a comment. And you can see that over here we're using load root to specify sprites as our root sprite folder. And here's our load asprite, and that is going to reference our Mario with our Mario PNG with our Mario JSON file, and do the same thing for our enemies. And the rest of the sprites will just be loaded normally using the load sprite method. So if you run your project at the moment, you should just see a blue background for now. Although we have loaded our sprites, we aren't using them just yet. So the first thing we're going to have to do is add our main level. So I'll just say add level over here as a comment. And you're definitely going to want to paste this one in from the text-based tutorial. We're going to add our level with various symbols. So basically we've got a levels array and we've got 2 main levels. So the first one looks like this. We're using various characters to represent different elements of the level over here, which we will go through a little bit more in just a bit. And you can see our second level over here. So make sure you paste your levels array in from the tutorial. Once you've done that, the next thing we're going to have to do is add our level and game config. So I'll say level config over here. And if you take a look over here, basically what we're doing over here is we are telling Kaboom which symbol to represent by which tag and which properties to give each symbol, right? So it does look like quite a lot, but we're basically repeating the same process for each of these game elements. So for example, we've got a question mark for a question mark box, an H for the castle. We are going to use an equal sign for the ground. So if you look up here, we've got the ground here. A pipe is going to represent one of those pipes that we can go into, although we won't implement that in this game. And we can see some question marks over here representing those blocks which we want Mario to hit. So for each of these, we pass in a function to specify a couple of properties. We obviously want to give each one a specific tag. So for example, this one has a tag of ground, this one has a tag of brick, etc., etc. And this is going to tell Kaboom exactly what to do with each of these symbols relating to our levels array. So in order to allow us to start our game, we're going to add a scene, and a scene is just a collection of logic that could relate to a level or certain part of your game. So if we go down here, we're going to create a start scene. So let me just say over here, start scene. So we're using the scene method to create a start scene. We pass in an arrow function. We're using the add method to add some text over here. So we want the user to push the enter key to start the game. As soon as that happens, we're going to go to our game scene, which we will create in just a bit. But for now, we just want to go to this start scene, right? So if we run this, we should be able to see our start screen. So now that we have our starting scene, of course, when we push enter, we want to go to our actual game. So we're going to create a main game scene for that. So I'll just say main game scene over here. Okay. So in order to create our main scene, we use the scene function. We call it game. We're going to pass in a level number, which is going to be a reference from our levels array over here once we add our level. And we also want to add our level config, of course, which we created up here, if you remember. And basically, this should allow us to add the necessary sprites at the positions that we want for our initial main scene of the game. We're adding a cloud, a hill, and a shrubbery over there. And we're just specifying with the pos method where we want them to be. Over here, we need to specify our layers for the game. So we've got background, the background layer, game, the game layer, and UI, which is the user interface layer. And by default, the game layer will just be the default layer, right? So instead of adding our Mario to our game by simply using our P symbol, we've got this level.spawn method, which is going to help us to reference Mario a bit better in relation to the level. And we are adding the text over here for which level we're currently on. And we want to add this to our UI layer. And we're basically going to use our level number over here to represent that. And one more thing to note is that when we're adding our level text over here, we're going to use this lifespan method over here to simply fade the text out after 1 second. So if we save this and we run our project, we've got our start screen. So if we push enter, we should go to our main game scene that has our level, right? Cool, and you can see our main game scene over here. And we've got our sprites, we've got our background. And if you look over here, our little enemy over here is actually moving. And that is because in our level config, where we added the enemy, we've actually got a custom animation over here when we add our sprite, which is a walking animation. So that is pretty cool. All right, so now that we've got our main scene up and running, the next thing we can worry about is actually making Mario move. And in order to achieve this with Kaboom.js, it's actually very simple. So I'll say Mario movement over here. And let's just use this formatter quickly. And you can see that we are listening for on key downs for left and right, and an on key press for the space, and that is for jumping, of course. The left and right on key down events basically listen for a constant pressing of a left or right, whereas the on key press will listen more for a button press kind of action from the user. So if we're going right, we want to flip our X axes of our Mario sprite, and we also want to do the same thing for left. So it's basically going to flip it left or right as we move left or right, and that will give the illusion of Mario turning around basically. And it's very simple in order to make Mario move, because we have this move method which comes from the pause method automatically from Kaboom, and we've just got a constant speed variable over here which we're using to set in that move method, set to 120 for now. You can play around with this if you want. Then finally, in our left on keep down event, we are checking if Mario has gone all the way to the left of the screen. So we're using toScreen for that, and we're checking player pause. And basically, if that's less than 20, which is kind of the size of the level, that means that Mario has hit the edge of the screen. So if that is the case, then we don't want Mario to move anymore. And for our jumping, we're basically just going to check if Mario is currently on an object, and we can simply use this grounded method for that. So as long as Mario is on an object or grounded, we're going to allow him to jump. Obviously, we need to check this, otherwise Mario would just be able to jump infinitely, and we wouldn't want that. So let's go ahead and test out our movement by running our project. So let's start the game. Oop, let's just scroll this down a little bit. And if we go right, we can go right, we can go left, and Mario is flipping around. Nice. And if we push space, we can jump. Nice. So one current problem that we have is, of course, we can move Mario around, although you can see that we can just kind of jump straight off the level, and the camera is not going to follow Mario around. So we need to fix this. So over here, I'm going to say camera scrolling. So in order to implement this camera scrolling, we've got this cam pause method from Kaboom, which does exactly what it sounds like. It gets the current position of the game camera, right? So in order for us to get the camera to follow Mario around the level, we're going to use an onUpdate event, which is attached to our player, which is Mario. And we're going to use a variable to get the current position of the camera with cam pause. Then we're doing a check to see if Mario's position has changed from the camera's position. If that is the case, then we're simply going to set our camera position to exactly where Mario is. So very simple. And let's test this out. Right, let's start the game. So let's jump over him. And you can see now that our camera is following Mario. So we can now freely move around the level. Alright, so the next thing we can worry about is our enemies obviously aren't doing anything at the moment, and they're just kind of sitting there wobbling their toes around. So we want them to basically move around by themselves. And the way that we're going to achieve this is by creating what's known as a custom component in Kaboom.js. So I'm just going to show you an example of a custom component for now. So this is kind of a skeleton for a custom component. So as you can see, it's a function that can take in whatever arguments you want, and it's going to return an object with a couple of required fields here. And these custom components are basically going to attach themselves to whatever game object we want so that we can have better functionality and more custom functionality as we desire. So if you look over here, we need an ID to reference whatever custom component this is, and this require field over here is going to basically reference whatever other components this component is going to need in order to work. And then we've got add and update methods over here to change our game elements as we desire in relation to this custom component. So now that you understand what these are, let's go ahead and implement one for enemy patrolling. Alright, so let's go ahead and implement our custom enemy patrol component, and we're going to want to do this outside of our main scene. So if you go down to the bottom here, I'll actually make a comment to say custom components. Right, and the first one we're going to have is for enemy patrol. Okay, so here's our custom component over here. It's a function called patrol. We've got a distance that needs to be accepted and a speed with defaulting to 150. And this dir or direction variable is just going to reset the direction of the enemy. So it's either going to be 1 or 0 pretty much. So we're giving our custom component a ID of patrol. We're going to require the pos and the area components from Kaboom because we need to use them here. So we've got a starting pos, which is basically 0, 0. And we're just going to use our add method over here to say that we want the starting position of this enemy basically to equal the position of wherever the enemy was basically. And then we're using a onCollide over here to check an object and a side, and we're just saying if the side is left or the side is right. So that's basically if this current enemy has hit a left or right side, which could just be any object really. And if that does happen, what we want to do is swap our direction, and we just do that by subtracting 1 from our direction variable, right? So that way they'll go in the other direction. Then we've got an update method over here, and we're basically just doing a check using our x pos and our x starting pos, and we're subtracting our starting pos from our pos to basically get the actual position. And we're just saying if that position is less than or equal to our distance, so distance is currently 100, remember? So that is our current patrol distance basically. So once we reach our patrol distance, we of course want to flip our player to move in the opposite direction again. So that is handled by the move method over here to move at that current speed, which we also pass in here as 50. We want to times that by our direction, which is going to be either 1 or 0. And that's going to help us to have our enemies patrol around the screen. But in order to make this work, if you remember, when we added our level config up here, so you can see here for our enemies, which we represent by an E, we've got this patrol. We've got this patrol method over here that is commented out now. So if we uncomment that, and we pass in 50 as the value we want to patrol with, and we save and restart our project. Oh, looks like we've got a bit of an error here on line 295, so let's have a look at that. Looks like we had an extra bracket here. So let's just go ahead and fix that and restart our project. Cool, so let's start our game. And you can see that now our enemies are moving all by themselves using our custom patrol component. Cool, so now what we're going to need to do is create another custom component, and this one is going to reference our enemies. Particularly when Mario jumps on one of them, we want that enemy to be squashed. So over here, I'm going to say enemy component. Okay. So we've got our enemy custom component here. We've got an ID of enemy. We're going to require the position component from Kaboom, the area component from Kaboom, sprite as well, and we're going to need our patrol custom component as a dependency to this one. So that's this one, of course. And we need that because obviously when we squash an enemy, we want him to stop patrolling. If you have a look over here, we've got our squash method, which we are going to execute every time Mario jumps on an enemy. We obviously want to set that instance of isAlive to false. And we've got these use and unuse methods, which are currently undocumented by Kaboom. But basically, we're going to use our patrol component, or we're going to stop using that, of course, so that that current enemy stops patrolling. We also want to call stop on that, and then we're basically going to alter the sprite of that enemy just to seem as if Mario has squashed him. Then we've got our lifespan method again here, just to fade that enemy out. So first off, we need to go back to our enemy inside our config file. So over here, our E tag for enemy, and we just want to uncomment our enemy call over there to our custom component. Then if we go back down over here, inside of our main scene, we're going to need this logic over here to squash an enemy. So I'll just say squash enemy over here. And let's just format this a little bit. So we've got a variable to keep track of whether we can squash the enemy, and we're attaching an onCollide method to the player object over here. And we want to check the bad guy tag, right? So we pass in an arrow function here for each baddie. And we're saying if that baddie is alive as false, then we want to return because he has already died, of course. And if can squash is true, then we want to squash that baddie, right? So we want to do some stuff here in this else, but for now we just want to take care of squashing enemies, so that's cool. So you're also going to want to go back to where we created our onUpdate event for our player, and we just need to add in here the case for if our player is currently on the ground, we want to set our can squash to false. And we also need to modify our space on keypress handler for jumping and just add over here to set can squash to true because Mario has jumped and he might land on an enemy. Cool, so I believe we should now have the logic to squash our enemies. So let's test it out. Oh, let's just run our project. And open this up. Let's start the game. And if we jump on an enemy, we should be able to squash him. Oops. If I could probably... There we go. We are able to squash enemies. Awesome. Alright, so that's gonna do it for part 1 of building Mario. Please do stay tuned for part 2 where we will finish off our game by adding functionality to grab our reward boxes, give Mario his classic big and small states and more. So I hope you guys have really enjoyed the tutorial so far, and I'll see you all in part 2. Bye bye.